Okay, I'm going to show you how to solve or fill in the chart for question 9 on the unit review. This is very similar to part 2 of the kinetics graphing assignment, where you had to fill in the chart before you could make your graph. So the first thing you need to do is look at your balanced chemical equation, and that is going to tell you how to get from the concentration of N2O5 to the concentration of NO2, and then also from N2O5 to O2. So what we would do is we would take, because we're starting with N2O5, okay, we're just going to use the mole ratio. Okay, so I set up my fraction. It's N2O5 that I want to cancel. And I'm first going to start with NO2 that I want to get to. Okay, now into here is where I put my coefficients. So I'd put a 4 for NO2 and a 2 for N2O5. And we would see that that equals, whoops, 2. Okay, so that's just telling us that as we look at the concentration change of N2O5, the concentration change of NO2 will be twice as much. It will be happening twice as fast. Okay, so over here, I'm going to do the same thing, but with O2. So N2O5 on the bottom, O2 on the top, and O2 has no coefficient, so 1, and N2O5 has a 2. Okay, so this is just saying that the change in concentration of O2, it changes half as much as N2O5. Okay, so in order to utilize these, we have to see, first of all, how much is this concentration changing between time periods. So our first two time periods are from 0 to 2 seconds. So how much is N2O5's concentration changing? So you just subtract these two values. So 0.65 subtract 0.49 is 0.15. Okay, so what you do then is you take that value, and let's start with NO2. So I'm just going to do my work for NO2 over here. So I'm going to take the 0.15 and I'm going to multiply that by 2. Okay, so I'm saying the change in concentration of N2O5, it changed by this amount, and I know that NO2 is going to change by twice as much. So that equals 0.3. Now, one important thing to remember is you always need to take that. This is the change in concentration. So it has to always be added to the previous value in the chart. So in this particular step, the previous value for NO2 is 0. So there, you would just simply write in the 0.3. But in subsequent steps, you'll always have to add your calculated value to the previous value on the chart. So I'll show you one more entry into the chart just so you can see that. Okay, so now to do oxygen, we'll do oxygen over here. I take the 0.15 and I'm going to multiply it by 0.5 or divide by 2, whichever you prefer. And that would equal 0.075. All right, so the value of 0.075, because you're, oh, hang on here. Okay, let me try that again. Your value of 0.075 can just get entered into the chart here because the previous value is 0. So when you add them together, still equals 0.075. Let's do one more entry so you can see how to add to a previous value. So we're gonna calculate the difference here, the change in concentration. So 0.49 minus 0.36 is 0.13. So I'll start with NO2. So I'm going to take the 0.13 and multiply it by 2. Whoop. Okay, so that equals 0.26. Now, I don't just go and add 0.26 into the chart. So you have to add the 0.26 to the 0.3 because this is how much the concentration is changing by, not what the concentration is. So 0.3 plus 0.26 equals 0.56. So it's the 0.56 that I put into the chart. Okay, so let's do the same thing for oxygen. So we're going to take our 0.13. Okay, so 0.13 multiplied by 0.5, oops, is equal to 0.065. Okay, so again, we don't put the 0.065 in the chart. We have to add it to the previous value. So 0.075 plus 0.065 is equal to 0.14. So that is what I would now enter into the chart. And then you just keep going along in that way until you complete both columns.